Let's now look at the individual bones that make up the skull. We'll begin with the mandible. Let's look at some general features of the mandible to begin. So what we have here on the lateral aspect of the mandible, we can see the ramus of the mandible. The ramus becomes the angle of the mandible and then reflects onto the body of the mandible. So we have the ramus, the angle, and then the body of the mandible. There's a couple of features here on the superior surface of the ramus, the condyle of the mandible, the coronoid process, and the mandibular notch. The condyle is what is responsible for articulating with the mandibular fossa on the base of the skull. The condyle inserts into the mandibular fossa to create the temporomandibular joint, a synovial joint which allows for the mandible to move up and down. When we look on the medial surface of the mandible, we'll see some more things. First, underneath the condyle, we have what is called the pterygoid fossa. The pterygoid fossa serves as an attachment point for the lateral pterygoid muscle. Then we have an opening into the mandibular canal. The opening to the mandibular canal is protected by a small branch of bone called the lingula. As the mandibular canal goes through, it actually ends up creating a ridge along the medial surface of the mandible, which is called the mylohyoid line, all along here. Above the mylohyoid line, in this area here, you have an area for the sublingual gland, which is called the sublingual fossa. Underneath the mylohyoid line, you have another fossa for the submandibular gland, called the submandibular fossa. If we look at the very midline of the medial surface of the mandible, we have where this screw is. It's unfortunately blocking the genial spines. You are supposed to have superior and inferior genial spines. The superior genial spines act for an attachment point to the genioglossus muscle. The inferior spines serve as an attachment point for the geniohyoid muscle. Just underneath the genial spines, you'll have a short depression here in the very inferior surface of the anterior part of the mandible, and that's the digastric fossa. Serves as an attachment point for the anterior belly of digastric. Moving back up, and we're looking again at the mylohyoid line. The mylohyoid line serves as an attachment point for the mylohyoid muscle. Coming to the medial surface of the angle of the mandible, the medial surface for the angle of the mandible serves as an attachment point for the medial pterygoid muscle. Going back onto the ramus, we see as I told you, the pterygoid fossa for an attachment point for the lateral pterygoid muscle. The coronoid process serves as an attachment point for the temporalis muscle, which ends up going underneath the zygomatic arch and then fanning onto the faint temporal lines of the parietal bone. Moving back to the lateral aspect, looking at the lateral aspect of the mandible at the angle, this area serves as an attachment point for the masseter muscle. When we look at the anterior view of the mandible, we see two little holes here. These are the mental foramen, where the inferior dental nerve, a branch of V3, will be traveling through the mandibular canal, and as it exits out these foramen, the inferior dental nerve will become the mental nerve and give sensory innervation to the area of the chin. Continuing with the individual bones of the skull, let's look now at the temporal bone. The temporal bone features, as you can see here, the zygomatic arch. As I discussed before in one of the other videos of the general overview of the skull, we have the mastoid process, the external auditory meatus, and unfortunately we do not have a very nice styloid process, which will be extending down here. If we look at the medial surface of the temporal bone, we see that it's divided up into a squamous region and a petrous region. Petrous region is simply means mountainous. So this is where this ridge is the petrous portion of the temporal bone. In the middle of the petrous portion of the temporal bone, you'll find a slight dip, which is an impression made by the trigeminal ganglion. So this area here would be the trigeminal impression. Let me see if I can turn that to give you an idea of where that is. On the posterior aspect of the petrous portion of the temporal bone, we're going to have the internal auditory meatus. Moving now to another bone, we'll look at the occipital bone, single. We have the foramen magnum, for which the spinal cord will exit from the brain. We also have these hypoglossal canal for the hypoglossal nerve. We have the occipital condyles, which is responsible for articulating. Occipital condyles, responsible for articulating with the atlas of the cervical vertebrae. The atlas is the first cervical vertebrae. If we move a little bit posteriorly, and not very pronounced, but we should have a posterior occipital protuberance. Moving then to the single frontal bone, you can see the superior border of the orbit is made up by solely the frontal bone. You see the remnants here of what should be the supraorbital foramen. The lateral border of the orbit is somewhat made up of the frontal bone, as is the medial border of the orbit. On the lateral view, you'll see this is where the frontal bone will articulate with the parietal bones to make the coronal suture. And at this area here, where the frontal bone will articulate with the parietal bones posteriorly, and then inferiorly you'll have the greater wing of sphenoid and the temporal bone back here. This area would be the pterion. The next bone we'll look at is the zygomatic bone. Zygomatic bone, if we can bring back the skull to give you an idea of what this looks like. This is the zygomatic bone going right on there. Okay. The zygomatic bone will articulate with the temporal bone. And you can see how the zygomatic arch is actually part of the temporal bone and not part of the zygomatic bone. Okay? There's not too many features that you need to know about the zygomatic bone on its own. Then if we look at the sphenoid bone, which is a beautiful butterfly-shaped bone, we have several features that we need to tell you about. We have the greater wings of sphenoid, which are paired. And then you have your lesser wing of sphenoid. It's a single. That's part of the body of the sphenoid. The sphenoid has many foramen that you need to know about. First, you have the optic canal. Underneath that, you have the superior orbital fissure. You have foramen rotundum, foramen ovale, and foramen spinosum. On the body of the sphenoid, you have the anterior clinoid processes, which extend inferiorly and posteriorly from the lesser wing. You have a depression for the pituitary gland, which is called the pituitary fossa. Then you have a projection of bone which comes up, which isn't very pronounced on this sphenoid, but it should come up, and it's known as it projects superiorly and is known as the dorsum sellae. Now the dorsum sellae together with the pituitary fossa make up the sella turcica. On the base of the sphenoid, you have an extension here, which are the medial and lateral pterygoid plates. The lateral pterygoid plate ends up being an attachment point for the lateral pterygoid muscle, and the medial aspect of the lateral pterygoid plate ends up being an attachment point for the medial pterygoid muscle. The projection that comes off the medial pterygoid plate and ends up being a little, it should come off here and project inferiorly, ends up being the most inferior extremity of the skull, and that is known as the hamulus. The hamulus is an attachment point for the pterygomandibular raphe. The pterygomandibular raphe will extend from the hamulus on the medial pterygoid plate and come down. If we can do this here, it will go from the hamulus of the medial pterygoid plate down to the back of the mylohyoid line, where the probe is showing now. And that serves as an attachment point for the buccinator muscle, and it also serves as an attachment point for the superior constrictor.